Hello, welcome back to lesson 4, part 2. And what do we do with data once we get it? That's my question. So, the data collected for a statistical survey or study are called raw data. Raw data can be really difficult to interpret. In order to describe situations and draw conclusions, we need to organize the data in a meaningful way. Two methods that we will use are frequency distributions and stem and leaf plots. Actually, there's three. We're also going to use histograms. First, we'll study categorical frequency distributions, which are a way to organize data that are divided into distinct categories, like gender, your class standing in school, or conferences for college football teams. A categorical frequency distribution is a table in which you list different categories, then count up how many individuals in a sample or population fall into each category and list those frequencies. So we're going to create a categorical distribution, frequency distribution here. It says 25 volunteers for a medical research study were given a blood test to obtain their blood types. The data are shown below. What would the categories for these data be and why? Well, they're going to be the blood types. So we're going to have O, A, and B, and AB. And we looked at blood types in 4.1. So we're going to use tally marks to tally how many O's. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So my frequency is 9. When you have a really big group, I kind of cross it off in the data and then tally one for one. But when we have a small data set, I can kind of count. So 1, 2, 1 in that column, none there, 1 in that column, and 1 in that column. So there's 5. We have a B, 2 B's, 2 more B's, 1 B, and another B. So 7 B's, and then an AB, 2 more ABs, and a 4th AB. And then if we count them up, we've got 14 and 11 is 25. And so that just documents that we did have 25 volunteers to make sure we had accounted for everybody. Use your distribution to write some conclusions on blood types in the population. Do you think that there's enough data for your conclusions to be reliable? I don't know. We're not going to sample size in this class. We will if you take our statistics course, but figuring out the right sample size is really important. So some things I can notice is in this group of people, in this sample, O blood is the most common, and type AB is the least common. Those are a couple of observations I can make from this data. Another type of frequency distribution that can be constructed uses numerical data. It's called a grouped frequency distribution. In a grouped frequency distribution, the numerical data are divided into classes. For example, if you gather data on the weights of people in your class, there's a decent chance that no two people have exactly the same weight. In that case, everyone would be a separate category, and each category would have one weight in it. This, of course, would make the frequency distribution no more useful than the original list. So it would be reasonable to group people into weight ranges, maybe as 100 to 119 pounds, then you go to 120 to 139 pounds, and so forth. In the 100 to 119 pound class, we call 100 the lower limit and 119 the upper limit. With these ranges, where would we put someone who weighs 119.8? So that's a good question. I would round them up to 120. Okay. So it says, as question 4 illustrates, the way we choose classes is dependent on how the data values are rounded. The weight classes we chose earlier would be fine if all the weights were rounded to the nearest pound. But if weights were rounded to the 10th of a pound, we'd want to make the classes 100 to 119.9 and so on. So you have to just decide if you're going to round to whole numbers or use decimals. So these are the steps that you're going to go through to construct a grouped frequency distribution. You're going to decide how many classes you want to divide the data into. Between 5 and 15 is acceptable depending on the number of data values in the set. We will be giving you the number of classes to divide your data into. So to determine the width of each class, you're going to take the largest data value minus the smallest divided by the number of classes, if we haven't already given you classes. Then round this value up to the next biggest whole number. Use the lowest number in the data set or a nice number lower than that number for the lower limit of the first class. Add the class width to the first lower class limit to get the second lower class limit. Do this for all classes. Find the upper class limit for each class by subtracting 1 from each lower class limit. Tally up the number of data values in each class, then put the frequencies next to each class in a table. So this might seem a little overwhelming, but we're going to keep coming back to the steps as we walk through them together. In this example, so it says, we'll illustrate by organizing the following data, which are the record high temperatures for each of the 50 states in degrees Fahrenheit. So we have Alabama all the way through alphabetically through Wyoming. Why would a categorical frequency distribution be a bad idea for these data? Because there's only one category, temperature. Well, actually, there would be 50 categories if you did by state. There would be 50 individual categories. If you went by state. Okay, so we're gonna go through this together. So it says, first we're going to decide how many classes we want. The lowest temperature in the table is 100 and the highest is 134 for a span of 34 degrees. That would be the range. With 50 data values, somewhere in the neighborhood of 6 to 8 classes sounds reasonable to me. Any more than that, and we'd probably have many classes with just a couple values in them. It occurred to me that the span of 34 is close to 35. And 35 divides evenly by 7, so I chose 7 classes. So you're just kind of going by some reasonable numbers. So 134 minus 100 divided by 7 comes out to be 4.9. And remember, you have to do this subtraction first and then divide. So we're going to round up to 5 degrees. So each class will cover a range of 5 degrees. So step 3 says decide on a lower limit for the first class. The lower data value is 100, and if we start there, classes will have nice, easy boundaries. So that'll be nice. We'll start right at 100. Find a lower limit for all the other classes, starting at 100 and adding the class width of 5. So 100 to 105 to 110, 115, 120, 125, and 130. Find upper limits for each class. All of the data values are whole numbers, so we won't need a decimal part on our class limits. So we're going to subtract 105 subtracting 1 is 104, 110 subtracting 1 is 109, 115 subtracting 1 is 114, and so on. Set up a table and build the group frequency distribution. We set up the table with the class limits that we chose, then go through the data values one by one, putting a tally mark. And so here we did. So we just making sure that this adds to 50. 3 plus 8 is 11, plus 16 is 27, plus 13 is 40, plus 7 is 47, plus 2 is 49, plus 1 is 50. So this totals to make 50. So we have all 50 states. Write down at least 3 observations you can make from analyzing your frequency distribution. So one that I see is the majority, meaning over half of the data, the majority of states had a high temp between, so over half the states would have to be over 25. So I'm going to go with these two frequencies together, 16 and 13. So between 110 and 119. That's one observation. The second one I'm going to say is only one state had a high temp between 130 and 134. So there's only one of those. And I think one interesting is that even with Alaska, right? Even Alaska doesn't have their highest temp below 100. So all 50 states have a high temp of at least 100 degrees Fahrenheit. So on the worksheets, when I ask you to make some observations, these are kind of observations that you're looking for. Where is most of the data? Where is the least of the data? Are there any surprising data points? Okay, number 7 says, the data below represent the team record for wins in a single season by all current Major League Baseball teams. Organize the data into a group frequency distribution. So we have to decide on how many classes we have. So it says we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 3, so there's 30 teams. And 30 is divisible by 6. So 30 divided by 6 is 5. So I'm going to go with 6 classes. And I've got 30 teams. Let's see. So I'm going to do 6 classes, and then we have to go the lowest number of wins. I see 92. It looks like 92 is the lowest. And let's see what our range is here. The highest number of wins, I see 116. Looks like 116. So the highest number, the wins span by 24. Make sure I see that. And so 24 divided by 6. I did not do that. So 24 divided by 6 is equal to 4. So I'm going to have 6 classes, and the width is going to be 4. Okay, then my third step is going to be, remember, our third step, we're going to keep referring to this page 431 here. Our third step is use the lowest number in the data set or a nice number to find the first lower limit. So I'm going to do my class, and then my tally, and then my frequency. So I'm going to start with, we go from 92 up to 120. So how about we start with 92? So 92, 93, 94, 95, and then it'll be 96. So we'll start with 92, 96, 100, 104. Oh, so that, will that quite cover it? I'm not sure it will it? 92 to 96, 96 to 100, 100 to 104, 104 to 108, and 108 to 112. But 112 means it has to go up to 16. So we could say 116 plus actually has a width of 5 because there's another number in there. So this is 95, this is 99, this is 103, this is 107, this is 111, and I'm going to say 112 plus. Now, I could have done 5 classes, and then my width would have been 5. Excuse me. And if I started at 92, I would have 92, 97, 102, 107, 112, 1, 2, 3, 4, 5. I still have the same situation. Because 24 divided by 5 is not quite 5, but I rounded up to 5. So I'm just going to do the 112 plus, and I just put the plus there to recognize I just went just above my width of, which would have been 115. So I've got 92 to 95 is what I'm looking at here. 92 to 95. So I see 2. Then 96 to 98. I'm sorry, 96 to 99. So I found 6 in that corner. So I've done 2 and then 6. And then 100 to 103. So 100. To 100 to 103. Okay, so I see 7 in that group. 104 to 107. 1, 2, 3. And I got 6 again. 108 to 111. Okay, and then 7 in that group, and then 112 plus, so that 116 goes here, 114 goes there, the other 116, so 3. So let's count them up. So we have 8 and 7 is 15, and 6 is 21, and 7 is 28, and I have 31. But I said I had 30 teams, so I must have counted this incorrectly. I'm thinking it was either 6 or 7. So 96, 1, no, 96, 1, 2, 3, 4, 5, 6. This one here, 100 to 103, 1, 2, 7. Oh, it's because this was only 6, not 7. There we go. So we have 30 teams. You probably found it before I did. Good for you if you did. So it says, once we've organized data into a grouped frequency distribution, we might find it useful to illustrate those data graphically using a histogram. A histogram is similar to a vertical bar graph in that the heights of the bars correspond to frequencies. There are a few differences, however. First, the width of the bars have meaning. It's representative of the class width. Second, the bars are drawn right next to each other with no space in between. That's because the numbers are quantitative and they go in order numerically. Finally, the most important difference is that the boundaries of the classes are placed on the horizontal axis rather than the names of the categories. Okay, so here is how we draw a histogram. Write the scale for the frequencies on the vertical axis and the boundaries of the classes on the horizontal axis. Put labeled tick marks at the lower boundary of every class. So I'm going to have, we go from anywhere from frequencies of 2 to 7. So we've got 1, 2, 3, 4, 5, 6, 7. Okay, so we're going to start with 0 there and go 1, 2, 3, 4, 5. Oh, this is back from our state data. I forgot about that. So we're using our state data that we did in the solved example. So the highest we have is 16. So I'm going to have to change this up. So I think I might go by twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to do that. So it's going to be 2, 4, 6, 8, 10, 12, 14, 16, and 18. And we had 1, 2, 3, 4, 5, 6, 7 classes. And the lower boundaries start here. So our first lower boundary was 100, then 105, 110, 115, 120, 125, and 130. So the first group, 100 up to 105, there were 3. So we're going to go between the 2 and the 4 and mark that. And I'm going to write it above so you can see which group we did. The next group right here, the 105 to 109 had 8. So I'm going up to 8 and I'm marking that bar, and it's nice. They already gave us little hash marks that we can use down here. And that was 8. The next one is 16. So we're all the way up to 16. The next one is at 13. So between the 12 and the 14. Seven is the next one. So between the 6 and the 8 here. And we have 2 and 1. That is a histogram. So it says next, label the vertical axis with a scale that will make the highest frequency in the distribution fall somewhere near the top of the graph. So it says on the axis below, label the horizontal axis by marking off all the lower class boundaries from the frequency distribution. We did this. So we did 9, 10, and 11 just by drawing it without actually walking through them. So because of space, I only marked my lower class boundaries. Just mark that lower class boundaries. And let's look at the note at the bottom. It says, note, statisticians will sometimes label the horizontal axis of a histogram a bit differently to make it clear which class of value right on a class limit falls into. For example, assuming that you labeled 100, 105, 110, which we did, it's not clear whether a temperature of 105 lives in the bar or in the first bar or the second. If it's unclear at some point what values a given bar represents, refer to the frequency distribution for the data. And that's kind of what we did as we made them. Great job. So the last type of plot that we're going to do is called the stem and leaf plot. Another way to organize data is to use a stem and leaf plot, sometimes called a stem plot. Each data value or number is separated into two parts. For a two-digit number such as 53, the tens digit 5 is called the stem, and the ones digit 3 is called the leaf. For the number 72, the stem is 7 and the leaf is 2. For a three-digit number, say 138, the first two digits, 13, are used as the stem, and the third digit, 8, is used as the leaf. For values rounded to the tens place, like 8.4, you can use the value to the left of the decimal place as the stem and the tens place as leaf, as in our next example. In any case, the very last digit is used as the leaf, and what comes before is the stem. Note that we'll include a key with our plot that clarifies what the stems and leaves represent. The following data are the January 2019 unemployment rates for each state. So we again have listed from Alabama to Wyoming. So let's walk through the example. The logical choice of stems here is the digits in the ones place, and the leaves will be the digits in the tens place. Notice that the digits 2, 3, 4, 5, and 6 appear in the ones place, so those will be all the stems. We then go through the data one by one and write the leaves next to the appropriate stem. So the key here, the important piece is the key at the bottom. 6 with the bar 5. This is really 6 with a bar 5. It's hard to see. It means that 6.5. So this is where it breaks between the stem and the leaf. So this 5.1 means that there was a 5.1 for a state had the unemployment of 5.1, and that was New Mexico. And then there's also a 5.2. Does everybody see that? A 5 and a 2. So it's not 5.12, it's 5 and a 1, and then 5 and a 2. And the state that had 5 and 2 was West Virginia. Very low unemployment in 2019. Okay, so if we look at this again, it says, notice the key at the bottom. This is really important for letting the reader know exactly what the stems and leaves represent. There's nothing wrong with our plot at the moment, but to make it a bit more organized, it's customary to rearrange the leaves by increasing order. So our final plot looks like this. So notice here, they made the plot by just listing them, kind of going through the list one by one, but they're kind of all mixed up. So it's hard to see in the 3 grouping where they had unemployment in the 3%. They're not grouped together. So it's hard to see that some of them were at 3.8, 3.9, 3.7, and there were a few that were at 3.0 and 3.1. So by reorganizing on page 437, we can see that the majority were higher up here at 3.7, 3.8, 3.9 rather than lower. Again, write at least 3 observations about the unemployment data from looking at your stem and leaf. So I would say there was only 3 states above 5%. I think that's a good one to recognize. And then I would say the majority of states, again, more than half of states were below 4%. That's good. And the lowest unemployment for a state was 2.4%. So deciding on stems and leaves for the unemployment data was fairly simple because there was a natural choice of stems, the whole number part of each rate. That gave us a reasonable number of them, 6. That's not always the case For the high temperature data earlier in the lesson, the natural trace of stem would seem to be the first 2 digits, but here's what the stem and leaf plot would look like in that case. Explain why the stem and leaf plot isn't really helpful in organizing the data. I think it shows similar to what we had here, right? So, because most of the data is in the 110s group, and so it kind of looks clumped. I guess that's the only thing I can see that's real bad. In general, it's a good idea to choose stems that are between 5 and 15 categories. In the case of the high temperature data, we'd get a better organization if we divided the categories in half so that the first category covers 100 to 104. You can see that here with a little 0. And then the next category is 105 to 109. To signify this, we can use the little symbols with the zeros here at the top. Complete the stem and leaf plot for the high temperature data on page 432. We've helped you start by including the first 4 stems. Don't forget to include a key. So would be means. Okay, so we have the 100s, the 110s. We have the 120s and the 130s, right? So we have 120, 125. And then we have 130. So the 4 goes in here, the 134, one state. And there were, let's do the 120. So 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. And then 1, 1, 2, 1, 1, 2. And then we had 5 and 8. 125 and 128. I'm going to go up and do the 10s. So we have 0, 0, and 4 are the only ones in the first. 0, 0, and a 4. And then we have a 5. So 5, 5, 6, 6. So we have 5, 5, 6, 6, 7, 8, 9, 9. 7, 8, 9, 9. Then in the 110s, let's look at those. We had 1, 2, 3, 4 zeros and a 1. So 1, 2, 3, 4, and a 1. And then we had 1, 2, 3, 4 twos. 3, 4. And then 3 threes. And then 4s, we had 1, 2, 3, 4 4s. Well, that's interesting. There's still a lot in that, just the 110 to 114. And then we had 2 5s and a 6, 5, 5, 6. And then we had 3 7s. 1, 2, 3, 4, 5, 6 8s and 9. 1, 2, 3, 4, 5, 6, and 9. Okay. Describe why this stem and leaf plat makes it easier to analyze the organized data than the preceding one. Because you can, I like this. Look, we're going to talk about that later, but it really shows where the data is centered better. Shows the center of the data more clearly. I'm not sure on the English of that. Okay, the last question. It says compare group frequency distributions in stem and leaf flats. How are they similar? Which do you think makes it easier to analyze a set of data? So the grouped frequency you can see the big ideas. So what I'm saying is in the group frequency, you can easily see the big ideas. Like I say, oh, the highest is here. The lowest is here. You see that, the generalities. But the stem and leaf, you still see the big ideas, but you also see the raw data. Because of the way it's displayed, you're still seeing all the raw data. And I think that's really valuable. That ends lesson 4.4. So catch me back for lesson 4.5.